So welcome to Unit 7, guys. We are looking at quadratic functions and specifically graphing them in this video and what their characteristics are. So first, let's dive into some key vocabulary that you're going to hear me say a lot. So first of all, a quadratic function, what they are, it is a non-linear, which just means not a straight line. So nonlinear, and it can be written in the form ax squared plus bx plus c. And so you are familiar with that, but let me just keep going. Specifically, a cannot equal 0, which that makes sense because if a were to be 0, that would eliminate my power of 2, then making this a linear problem. And so what this is, this formula here, you're familiar with that being standard form of a quadratic equation. So ax squared plus bx plus c. And so I'm going to reference that a lot. I did reference that a lot in the last unit as well, but in case you didn't know that, that is standard form. So a parabola is the shape of a quadratic function. Quadratic function. And parabolas are symmetrical. And symmetrical just means it's almost like if I were to cut it in half, it's reflected on the other side. And so that actually helps us graph that little fact right there. And so that symmetry comes from the axis of symmetry, that line that literally cuts it in half. So that is the central line that cuts a parabola in half, okay? And then a parabola is a U shape. And we will either have a minimum, which is the lowest point. So that's kind of easy to remember. Sound is how that sounds. Or we will have a maximum, which is the highest point. And so I kind of have some examples here where, okay, here is my parabola. I want to point out some of the vocabulary that we just talked about. So first of all, let's talk about let's go in order. Here's our axis of symmetry right here, okay? So you could even arrow and say, okay, that's my axis of symmetry. So you see how it cuts it right in half. Then I have a minimum, that's my lowest point. So I would say this is a min, and I usually do min for short. Then in the other one, okay, here's my line of symmetry. See how it's cutting it right in half? So if I were to fold on that line, it would lie on top of each other. And then here I have a high point. Whoops, hold on a second. I have a high point right there. So then I would call that a max or a maximum. So let's just get practice with graphing. How do we graph a parabola? So one of the strategies to do so, just kind of like how we did with our linear equations, is we can pick 5 numbers, and maybe this will ring a bell. We could pick -2, -1, 0, 1, and 2 into the equation and see what we get out. So something to keep in mind, something very important, is that when you are substituting in, always use parentheses, because when I put in -2 like this into my calculator versus this, you're going to get 2 different answers. This is going to shoot out 4, and this is going to shoot out -4. You want to always put things in parentheses. So, and when I plug in -2, my work would look like this. I would do 3 times -2 squared plus 6 times -2 minus 4. And then if I simplify that and you plug that all into your calculator, it will spit out -4. And so that's my first point, -2, -4. So on my graph, it'll let me, come on. Sorry, my technology is failing me today. That would be my first point, -2, -4, and then I'll put in -1. So it is kind of a time-consuming, a little tedious, but it is feasible. So there I've plugged in -1, and out will come -7. And so then I go to -1, -7. Gosh, why is it is not working with me. Then I'll plug in 0. So I put 0 and I'll square it. Notice again how I'm just going to emphasize that I'm putting things in parentheses. So when I plug in 0, out comes -4. All right, and you can kind of see that U shape forming. So then I'll plug in 1, I'll square that, plus 6 times 1, minus 4. And when I plug that in, I get out 5. And so I go over to 1 and up to 5. And there's another point. And then finally, I'll put in 2. So 3 times 2 squared plus 6 times 2 minus 4, and out would come 20. Now 20 is not going to fit. That's okay. Like if you really felt the need to, you can kind of just say, oh, it's going to be somewhere up here if it'll let me. Okay, but I could see this U shape forming, and so I just kind of connect the dots and I just kind of sketch it on the other side to the best of my ability. So off to the right, you'll see domain and range. So I don't have much room to write over there, so I'm going to write it down here. So my domain, remember domain are your x values. So my domain in this case is going to be all in real numbers, so or infinite. So I would write my little bracket, and so x is going to be greater than all the negative numbers, so all negative numbers to infinity, and less than all the positives. Okay, that's a terrible infinity sign. Let us try that again. There we go. And then your range is more restricted. So your y values are restricted to when y is greater than or equal to -7, because that's my minimum. Okay, that looks like a 71. Let's try that again. There we go. And so that's how you would graph. So let's look at another example. So same idea. I'm going to pick those same 5 numbers. So -2, -1, 0, 1, and 2. And again, I'm going to use parentheses when I plug that in. And when I plug in -2, I get out 7. And then -1, excuse me. So if you're wondering, like, how am I getting these numbers? Okay, well, you could, like I said, you could plug these into the calculator or do them in your head. I know -1 squared is 1 plus 3. Well, that gives me 4. And then I'll plug in 0, and that's pretty quick because I'll get 3. Plug in 1, and that will give me 4. And then plug in 2, and then that will give me 4. And if you kind of notice, there's a bit of a pattern when we plug in these numbers. You see some repeats. Oop, I just realized I made a mistake. This should be 7. I apologize. So now I can plot those points. So when I plot -2, 7, that'll be -2, +7, which is about right here. It does not want me. There we go. And then -1 and 4 will be right here. Man, graphing is going to be tough. 0 and 3 is right here. And then, come on. And then 1 and 4. So you can kind of see the symmetry starting to build. And then 2 and 7. All right, and then I just go ahead and I connect all those dots. And I put arrows because it goes on forever. And again, my domain, so all my x values will always be infinity. So x can be greater than all the negative infinite numbers and less than all the positive infinite numbers. And then my range, I have terrible infinity signs, by the way. But my range is limited, okay, for all my y values will be greater than or equal to 3. There's my minimum. So right here, those are all my y values. So now we're just going to go ahead and identify our characteristics of parabolas, which is the vertex, your axis of symmetry, your y-intercept, and the zeros. So your vertex is always going to be the max or the min. So in this case, I have a minimum, and it's going to be a coordinate, and that minimum is right here, and that's at -1 and 0. And then my line of symmetry, that axis of symmetry, is what cuts it in half. So if you can go all the way back to Unit 4, when we did linear equations, remember a vertical line is an x equals. So that line is x equals -1. Then my y-intercept's the same as Unit 4 as well. It's just where does that parabola cross the y-axis, which is at 1. So I would say 0, 1. And then my zeros are also like Unit 4 in that where does the line cross the x-axis? And there's only 1 0 in this case, and that's at -1 and 0. Or you could just say -1. So then in the next example, my vertex, I see here that I have a max. So that max is right up here, and that's at the point 0. Let's see, I gotta count 1, 2, 3, 4. Then my axis of symmetry, this one's interesting. It's actually the y-axis, which is when x is equal to 0. That's the line. My y-intercept happens to also be 4. Now my zeros, this one's like a better example of your zeros. So I've got zeros here, and I have them here. So I would say my zeros are -2, 0, and 0, +2. And then our final example here, I see that I have a minimum. And that minimum is approximately that point there, which is 1 and 3. My axis of symmetry, that line of symmetry, is going through x is equal to 1. I see my y-intercept is at 4, so 0, 4. And I like this one with the zeros. There are no zeros. Okay, so I'll say not applicable. All right, that parabola never crosses the x-axis.